Hello students, today my topic is about computer networking. Myself Payal Sharma, PGTCS, KV number 1, Jalandhar, Kent. Now let us start our topic. Today's topic is about computer networking, and it is the portion that I have selected is evolution of networking, and then switching techniques and data communication terms. Let us start our topic. Now you know what is a network. Computer network is a group of computers connected with each other through wires, optical fibers or optical links so that various devices can interact with each other through a network. So what is the prime cause that we use the network is to share the resources among various devices. Now we know all the features of the computer network like communication speed, file sharing, backup and rollback, hardware and software sharing, security, scalability and reliability. Next is our topic is evolution of networking. What is evolution? How our internet established. First of all, in 1989, ARPANET came into existence. It was started to connect computers at US defense and different universities. It is only for defense purposes. Then in 1980s, the NSF net was created to make a high capacity network which is used strictly for academic engineering research. ARPANET was used for defense purposes, and in 1980s NSF net was created to be used by academic or engineering research purposes. After that, in 1990, the internetworking of all these networks, ARPANET, NSFNet, and other private networks resulted into internet. This is the evolution of internet. How we came to this internet world. First of all, we should know the basic terms of networking. First is nodes, which is also called workstations. Term nodes means it refers to a computers that are attached to a network for any resources that request for the resources. The nodes are always on the receiving end. And servers. Server is a computer that facilitates sharing of data, software or hardware resources on the network. So clients make the request to the server and server will facilitates that request according to the requirement given by the nodes. After that, what we initially need in a computer is network interface unit. It means if we don't have network interface unit, then we cannot interact or communicate it with the network. So it is an interpreter that helps in establishing communication between the server and the client. Next is IP address. What is IP address? Every machine on TCP/IP network has a unique identifying number, and that number is called IP address. Next is domain name. What is domain name? It is a way to identify and locate the computers connected to the internet. It should be unique. Next is URL, that is Uniform Resource Locator. It stands for Uniform Resource Locator. A URL is the address of a specific web page or file on the internet. For example, this is the example, the http colon slashes www.example.com/index.html. In this is a protocol, HTTP is a protocol, and www Example.com is a host name, and this is file name that is to be extracted from the server. Next, these are the nodes. All these PCs are nodes and which are connected to the server through a switch. These all are connected. These communicate with each other through servers. Next, what is server? It facilitates the sharing of data, software, hardware resources on the network. These are of two types, dedicated and non-dedicated. What is dedicated server? Which is specifically serving only for one single organization. While in non-dedicated server, a number of websites or people can have benefit from that same server. So this is shared. This server is shared among these websites, and while in dedicated server, only one organization or one website is hosted on a dedicated server. Next is NIC card. What is NIC? Network Interface Card. This is the network interface card. It is a hardware component which is present in your computer, and without it we cannot connect to a network. Next is MAC address and IP address. What is MAC address? MAC address is Media Access Control Address. It identifies the physical address of a computer on the network. When we are connecting our PC on the network, the physical address of the computer is called MAC address, which is of 48 bits hexadecimal address, and it is assigned by the manufacturer of the NIC card, that is network interface card. And what is IP address? IP address is Internet Protocol address. This is logical. This address is logical. As MAC address is physical and it is recognized mainly in LAN, it identifies connection of a computer on the internet. That is, it identifies a logical address of the PC on a system that is connected to internet. We have IPv4 and IPv6. IPv4 is 32-bit address and IPv6 is 128-bit address. And IP address is assigned by the network administrator or internet service provider. Next, as we know, there are two types of networks. One is peer-to-peer network and one is client-server network. What is peer-to-peer network? In peer-to-peer network, the PCs communicate with each other without any intermediate or without any server-client relationship. Each PC will send message directly to other PC. While in client server network, we have one clients list and other is server. These clients make requests over the net to the server and server will respond to all these requests. What is interspace? This is the future of internet. It is a software that allows multiple users in a client server environment to communicate with each other, to send and receive data of various types such as data files, videos, audio, and textual data. Interspace gives the most exceptional type form of communication available on the internet today. Next, we will read what is switching. In large networks, there are multiple paths from sender to receiver. The switching technique will decide the best route for the data transmission. Switching technique is used to connect the systems for making one-to-one communication. There are three types of switching techniques. First is switching, circuit switching, second is message switching, and third is packet switching. Message switching is not specified in this year's syllabus, so let's move on. First is circuit switching. What is circuit switching? It is a switching technique that establishes a dedicated path between sender and receiver. Dedicated path means, first of all, the circuit is established, then the data communication takes place, and after the data communication is over, the circuit is disconnected. Means it is a complete end-to-end path must exist before the communication takes place. And what is its main example? It is telephone network. Telephone works only when circuit is established. After the conversation, the circuit is disconnected. Next, this is image. This is sender. First of all, the path. There are many available paths, but this path is dedicated and this is established. After establishing it, the communication takes place, and after that the circuit is disconnected. Now, next is message switching technique. Message switching technique is a technique in which a whole method complete unit is sent to the receiver through intermediate nodes at which it is stored and forwarded. This is also known as store and forward network. Why? Each and every node stores the entire message and then forward it to next node. So, in message switching technique, there is no establishment of a dedicated path between sender and receiver. This is the example. These are the intermediate switching devices, and the message is completely stored in first intermediate switch device and then forwarded whenever there is next intermediate switch required. In this way, it will reach the receiving end. Next, last is packet switching. What is packet switching? It is a switching technique in which the message is sent in one go, but it is divided into smaller parts. Like message, it is not completely sent in one go. It is firstly divided into smaller parts and then these packets are sent individually. The message split into smaller pieces called packets, and packets are given unique number to identify their order at the receiving end. As each packet contains some information in its headers such as source address, who is sending the message, destination address, who is receiving this packet, and the sequence number. Means if we have 10 packets, then uh, during transmission, first packet may reach after third packet. So at the receiving end, each packet is sequenced according to the sequence number given in this packet header. Then packet will travel across the network taking the shortest path as possible so that maximum transmission can take place using shortest paths. This is the example. See, user A is sending orange packets and user B is sending blue packets. These are the switching nodes, intermediate nodes. There can be as many switching nodes, and the data is sent across the network haphazardly, means it is not in sequence, and at the receiving end the orange packets are distributed accordingly and blue packets are sent in different order. Next, now this image shows the whole working of the network internet. This is the client, and this is green is request path and this is return path. So our message is sent through the modem, and then in intermediate there are routers that are intermediate device that routes the packets to the best suited path to the DNS, then DNS will send it to the main server where the request is responded back, and the data packets are sent back through DNS and then back to the client. This is the whole working of internet. Let us see it through an video. So TCP breaks down information into packets. IP routes those packets across the global internet, and TCP then reassembles the packets onto the client machine. Now, next is what is channel? Channel is the physical medium like cables over which the information is exchanged in data communication. See, the sender is sending data and receiver is receiving. Yeah, the data is transferring physically on which medium is called channel. In popular network terminology, path over which data is sent or received is called data channel. This data channel may be a tangible medium like copper wire, twisted pairs, optical fiber, or broadcast medium like radio waves and other mediums. Next definition is data transfer rate. What is data transfer rate? The speed of data transferred or received over a transmission channel, measured per unit time, is called data transfer rate. Smallest unit of it is bits per second. One bit is 0 or 1, transferred in 1 second. Next, some commonly used data transfer rates are 1 bps, that is 1 bytes per second, 8 bits per second, 1 byte is 8 bits per second. Then is 1 kbps, that is 1 kilobits per second, which is equivalent to 1024 bits per second. Next is 1 mbps, that is 1 megabits per second, which is equivalent to 1024 kilobits per second. Next is 1 Gbps, that is 1 gigabits per second, which is equivalent to 1024 megabits per second. Next is 1 terabits per second, which is equivalent to 1024 Gbps. You can You should know the full form of all this as it may come in your exams. Next definition is bandwidth. What is bandwidth? It is the maximum data transfer rate of a network or internet connection. It measures how much data can be sent over a specific connection in a given amount of time. Okay, and the factors that affect network's bandwidth are network devices used like switch, hub, router, gateway, etc., protocols used, number of users connected, or network overheads like collision or errors. Now, let's take an example of a car going through several lanes on a highway. So, think your internet speed is bandwidth. Okay? It is like lanes on a highway, and your data as cars traveling with the same speed. So if there are more lanes, the faster you will get to your destination. In this way, if there is one single lane, one bit is traveling, then the your destination will receive the data slowly. So this is a example that is explained through your cars on the highway. Next, there are two ways we can use bandwidth, that is in hertz or in bits per second. What is bandwidth in hertz? It is the range of frequencies contained in a composite signal or range of frequencies a channel can pass. For example, we can say the bandwidth of a subscriber telephone line is 4 kilohertz. Similarly, different signals can be sent on different frequencies. Next is bandwidth is bits per second. That is, the bandwidth can also refer to the number of bits per second that a channel, link, or even a network can transmit. For example, one can say the bandwidth of fast internet network is maximum of 100 Mbps. This means that this network can send 100 Mbps, maximum data that can be sent into the network during a certain period. Next, you should know all these full forms that may come in your CBSE board exam. So these are PANET, Advanced Research Projects Agency Network. Next is NSFNet, that is National Science Foundation Network. MAC, Media Access Control. TCP/IP, Transmission Control Protocol, Internet Protocol. NIC is Network Interface Card, or NIU is Network Interface Unit. BPS is byte per second, P is capital. kbps is kilobits per second, mbps is megabits per second, gbps is gigabits per second, and kbps is terabits per second. These all are full forms, and this is a small worksheet that you can complete to revise this topic. Like you can have expand means full form type questions like expand, ARPANET, NSFNet, GBPS, TCP/IP, NIC, etc. Differentiate means we should this topic also includes these differentiations like differentiate between MAC address and IP address, circuit switching and packet switching, dedicated and non-dedicated server, and also some main definitions like bandwidth, channel, interspace, data transfer rate, etc. So this is the worksheet. I have also created a online networking quiz. You can go through this link, and this is the link of my internet, okay, quiz, online quiz, and thank you.